Okay, cleared some space on the board and put some new things up. This is a point where I like to pause and make sure we know what we're not doing. Bayesians rightfully, correctly get very upset with people who conduct frequentist inference for saying the wrong thing, for taking the meaning of the frequentist result, inferential result, which I believe is very powerful and very useful, taking the meaning of it and twisting it around to say the wrong thing. So we're going to be very careful. It's like its own little thing. Here's another representation of what we just did with the sample size of 10, very small. And so we're going to have big error bounds. We're not going to have, our confidence is not going to be great in any one score. So we had a 77 in the middle, and I did twice my standard error estimate on both sides, and since we have now the interval 66 to 88, if you want to make an inference, this is a worthless interval in the first place because it's so large. I already made that point, but it is what it is. It says that as we move on in the sampling process, the next 100 times, for example, the next 100 times that I take sample of size 10 and calculate an x-bar, I can expect 95 of those to fall somewhere in this interval. That's what this says. And I think that's a very powerful result, and realize we're using 10, and to picture it at the end last time is how we shrink the interval when we raise the sample size from 10 to 100 to 1,000 to 10,000. 10,000 is very rare for a sample to be that large. 1,000 is a very normal score. You can get really, really narrow error bands, and when you get the narrow error bands, the confidence intervals, what you say is that you're 95% confident that the next 100 times you sample, that you're going to get an x-bar with n equal to 1,000 that falls in that narrow range. What not to say. Never say that you're 95% confident that the mean of the population falls in the interval. That's not what this math says. That's not its intent. And critics of frequentist statisticians and frequentist inference in general, they're absolutely correct in criticizing practitioners for very, very often just saying in print that we're 95% confident that a population value falls in the interval. We're not. We're not. It could fall out. What we're confident of is that the next time we sample 100 times, 95 of those 100 will fall inside the confidence. Will fall inside the confidence interval. So, is the whole process then worthless if I can't say officially that I'm 95% confident that the population mean falls into the interval? Is the whole enterprise worthless? Well, of course it's not, and I would take issue with any Bayesian who says that it is. What we're doing here is using the central limit theorem to say something very, very important with using little data about a much larger number of units and giving us guidance. So if I ask you the question now, what do you think? So I'm leaving the objective sense and asking for your subjective opinion. Do you think it's more likely that the population value falls inside the interval or outside the interval? Now the Bayesian would say, this is what frequentists too often say, and they would be correct. But once you cross over, I say, what do you think is more likely? And I'll tell you what I think is more likely. If the process of random selection of the original data set was random, what I think is more likely is that mu x, the population mean, falls somewhere in here. I think that's more likely. That's what I think is more likely. I'm being Bayesian when I say that, because I have left the objective realm, the objectivist, frequentist, inferential realm, where I let probability attach to these things over here, to those things that we observe, and started talking about what I think in the subjective sense. And there is a model, and we'll get there, a model for subjective probability, and it's called Bayesian statistics. We'll get there, but we're not there yet. Next video is about this guy, V sub I vote, and putting confidence intervals around sample proportions, which are neat little things, as you'll see.